Okay, with that, I want to invite Matthew Lange, Professor Matthew Lange from UC Davis, if he has slides, to share them. Quick bio. He is a food and health informatician in the food science department at UC Davis with 20 years experience building data, information, and knowledge systems for academia, industry, and government operations. He is the PI and director of IC Foods, which is the International Center for Food Ontology, Operability, Data, and Semantics. IC Foods is dedicated to building global computable infrastructure for the Internet of Foods and the semantic web of food. Synergistic with IC Foods, he also co-leads the GODAN working group for alignment of authoritative vocabularies of food, and is designing ontological infrastructure for a new food central repository for the USDA food composition databases. He also teaches database and knowledge modeling in the Graduate Health Informatics program at UC Davis School of Medicine. And I'd like to add, I was so fortunate to be at the last IC Foods Summit, and I believe the next one is coming up. I don't know if I'll be there, but others might be able to make it in November. And what I really think is interesting about what Matthew is doing is he provides such an interesting way of organizing data that crosses several fields of people who wouldn't usually be talking to each other to bring new insights. It's really all the stuff we always talk about facilitating with infrastructure and great systems. And so much of that starts with the people networking, which is also what the Hubs is all about. So with that, please take it away.
Oh, Christine, thank you for such a nice introduction. Really appreciate that. Can everybody hear me all right?
Yes.
Terrific. Yeah. And you can see my title slide all right?
Yes.
Fantastic. So I use Google Slides, and if you want to take a minute and just write that down, that link, then you'll have access to the slides. And actually, there'll probably be a bunch more. So I've got one ending spot at about my 10-minute mark or 15-minute mark, and then I've got some dirty details after that if you're interested in diving into specific ontologies that we have. I do want to make one clarification. It's in a slide later, but since you mentioned it, we've moved the conference time and place actually from November to March, and this is a permanent move. Our first conference that we had happened over Election Day in 2016, and yeah, there you go. That's exactly what we were trying to avoid again. And as hot as the political nature of things are right now, made the executive decision that I don't want to be anywhere near an election day with a conference ever again. So we will be March 22 to 25 next year. And that is actually going to be after a full week of other food conferences. So we have the Agritech, the World Agritech Summit earlier in the week, and then Future Food Tech SF, and then IC Foods, which is dedicated to building the Internet of Food. So there will be, I think, 9 days in a row, 3 different conferences for people who are interested in food and technology. But today, I'm going to talk to you a little bit about the semantic web of food as we see it coming, and the Internet of Food. Now, the idea here is that we can build vocabularies for food that span from molecules to Earth observations, that span in dimension that way, that span in discipline from essentially agronomy to zoology. And it's a tall order. It's an ocean boiling exercise. But there's no reason that each one of these disciplines should be using different words for food. So, and what we see coming in the future, right? We've already got lots of sensors and robotics, and we've got this amazing cloud storage abilities. We were just hearing about NSF and petabytes of storage and things like that, and the new blockchain and distributed ledgers. And of course, now in the last half a dozen years, machine learning, AI, has come on strong for making sense of these massive amounts of data. And it's pretty easy that we want to make a better planet. we want to improve the health of people. And what I think is particularly important, and I harp on this when I teach medical students and particular people in the medical profession, is that food is really about performance and delight. Sometimes we eat food to get better, but generally we're eating food to nourish ourselves and to improve our quality of life as it is now, not to fix something that's gone wrong. So it doesn't exactly fit into the model of our healthcare system, which I think is actually misnamed. It should be called the disease intervention system, because you don't generally go to your doctor until there's something wrong. And the vast majority of the money that the NIH spends is on drugging, cutting, and irradiating the hell out of people after they've made a bunch of bad choices about food. We'd like to change that. So at its heart, the semantic web and Internet of Food is really based on a common language and infrastructure and methodologies to operationalize the vast amounts of data: environment, ag, food, diet, health. Now, if you think about it, I think it's pretty well agreed upon now that data and information emerging from the Internet of Things will be outsized the amount of data on the current World Wide Web. So by 2020, IoT will be bigger than www. Now, if you think about food being in flux through many of these devices, and we just heard Walmart wants to track food, making their suppliers use blockchain and tracking food through the supply chain. And I'll talk a little bit more about that in a minute. And all this information coming from soil sensors and weather sensors, and we have Earth observation data. So if you think about the amount of data about food, and then you consider omics about food, what am I eating? What is the metabolomics of the plant? And so it's pretty clear that food, since we all eat every day, influx through the Internet of Things, the IOF will actually be orders of magnitude larger than the IoT, which is it's kind of mind-boggling to think about the size of what we're talking about here. So our vision here with IC Foods is really to create a global technological infrastructure that's capable of collapsing the time that it takes to translate scientific knowledge into application, right? So this idea that we produce a bunch of data and then we write it up in a paper, and then someone comes along and uses natural language parsing to parse the meaning of the paper and then turns that into data, that's a little silly. We should be thinking about ways of fair and fairer sharing of data. And doing this not just for scientific data, but for company data, like the Walmart example I mentioned before. And that's really enabling companies to compete, to be more traceable, more transparent. And when we enable companies to compete to do that, rather than some kind of top-down regulatory view, then we're being more competitive. So we're improving the food supply here by enabling people to compete on the same things that we value for society and for individuals, to be more traceable, more transparent, and ultimately to produce better food, healthier food, more authentic, more sustainably produced. So when we're traceable and transparent, people are going to be able to make decisions based on how that corn was grown. Was the cow, massaged 3 times a week in order to get the steak, or whatever it is that you value? Maybe you don't care about pesticides, but you care about phosphates in the soil. How were these things grown? And ultimately, this means that there's going to be all kinds of new players in food systems. So we're looking at really democratizing food systems and having the same effect on players in food as you can imagine, the internet has had on commerce in general. So when we think about food and the value propositions for food, it's really kind of a no-brainer, yet we've been ignoring it all this time. Half of all greenhouse gases are related to food. Food transportation, food production, food processing. There's just a lot going on there, right? So solving for food is also solving for greenhouse gas emissions. And it's not just, a bunch of left-wing scientists and a scheme by the Chinese, there's a real cost of doing business associated with this. So Swiss reinsurance, the largest reinsurance in the world, has come out and said, if you don't have a climate solution in place for your supply chain, your insurance is going to cost you more. Moody's has said your credit is going to go down if you don't have supply chain solutions in place. Rabobank is investing heavily in technologies to improve sustainability in the food supply, and so is CalPERS. And when we build this infrastructure, we have to think not just about building this as a national infrastructure for private citizens and for government agencies, but also that there are these large players who essentially control both the national and the global food supply. And so we need to be thinking and engaging with these guys as well. And all of this is enabled by, of course, these pervasive sensors, IoT. Agriculture is the largest market for drones, and we all carry cell phones and are able to track our health with cell phones. So we're producing all this data from sensors, and we can be using this to improve our health and food supply. So the example that I often give is that every web browser understands HTML, hypertext markup language. What would it look like if we had a hyperfood markup language? Of course, those of you who are in the language and software space realize that I'm probably not talking about markup language, I'm talking about ontologies. But the idea is that I can annotate tomatoes, and not just any tomato, this tomato right here in a time and place with a level of ripeness, every aspect about that plant, because I've been monitoring how it grows with all kinds of IoT devices. So like I said, we're talking about ontologies, which is in the top right here highlighted. In terms of complexity and cost, ontologies are perhaps the most expensive type of vocabulary that we can use to both annotate and enable semantic technologies, but they are the most semantically precise. So we've developed a model for a food phenotype ontology. There does not currently exist a model for characterizing all foods at a class level. So what we've said is, look, every food has a biological component, from a milk fat globule membrane to a pork shoulder. Those biological components contain chemical components, and there may be additional structural components like a sheet of pasta. And these all have properties, biological properties. These could be bioactive properties when you consume specific yogurt, or chemical properties, pH, or what have you. Physical properties like how thick is that sauce, rheological properties, viscoelastic properties. And then there's this dependent class down here called organoleptic properties. And for those of you who aren't food scientists, this is the smell and the aroma, taste, even sound and sight of food. We're working with a very large flavor company right now to build out standardized terminologies for these organoleptic properties. And that's going to enable all kinds of predictability on flavors. And this is just a quick example of going into more detail than what the USDA currently has as its nutrient database and food composition database. These are oligosaccharides, these 1101A and all of these are labels of oligosaccharides, which are medium chain carbohydrates that are found in human milk and are known to grow specific gut bacteria to make the gut, to make the infant gut healthier. And these are all the cow, mares, donkeys, these are all the animal milks that contain similar oligosaccharides. So that if someone couldn't breastfeed, we could conceivably then create from a variety of other animal milks specific blends that would be precise milk that might feed that baby better. For those of you who are not familiar with ontologies, this is a quick look at the gene ontology. Whoops. This is a quick look at the gene ontology. Growing, there's 3 root classes: the biological process, the molecular function, and the cellular component. So I compiled a list of the ontology and then genes that were annotated against the ontology. And through time. So the purple guy that's floating around, those are all different databases where the gene was associated with the ontology terms. And this is kind of a cool visualization because what you get is this ability to watch our collective human knowledge grow through time. So I won't belabor that point. Just one real quick sort of mention here is that you can watch sort of, we have these like explosions of knowledge that happen when people make, there you go. So this is all immune system stuff happening but in the biological process and in specific places in the extracellular region. And then the action, the specific molecular action that those things have. Imagine now we could do that for food and nutrients within foods as well. Can you still see my slides? Okay, great.
Yes.
I lost my full screen. I just wanted to make sure. Okay, great. So this idea that we can build ontologies which would form the backbone of the semantic web of food. And goodness, go back. And we can annotate what I've got in quotes here, traditional data about food. That could be economic data about food. That could be sensor information about food. And we can lay all of this annotated data down into a distributed ledger or a blockchain. And all of this together comprises the IOF. And then this idea of the semantic web of food, if we were to drill into that, where we would get vocabularies, we've got indexing. So if you've ever done any ag research, you know that there is the CAVI thesaurus. There's also the Agricultural Vocabulary Service, National Agricultural Thesaurus. So we have these indexing vocabularies. We have vast quantities of economic and trade data about food, sociocultural data about people tagging food in social networks and things like that. Pictures of food on Instagram now outnumber pictures of cats, which I think is quite telling. And then we've got this observation, sensor data on the one hand and Earth observation on the other. And then, of course, the omics data that I was mentioning before. So this idea that as we model this, we've got the food phenotypes, which I mentioned earlier in the root classes. And then we've got the processes that interact with food phenotypes, the production, transformation, distribution, and consumption processes that interact and make those food phenotypes or consume those food phenotypes. Then we have the equipment and agents, this means people as well, that engage in processes that alter food phenotypes. And then we have essentially issues of the people or agents that are engaging in the processes that are altering the food phenotypes. And we've begun to develop ontologies at each one of these levels and using interoperable terms between them all. So at IC Foods, we've built working groups for building ontologies in each one of these areas. And I'm just going to move quickly now. Christine mentioned that we lead the International Working Group for GODAN. About once a month, we have calls with folks from the USDA, the FDA, EFSA, which is the European Food Safety Authority, the UN Food and Agriculture Organization, the WHO, and a variety of academics to begin to align these vocabularies. We have an RCN from NSF for building a smart food shed. So just getting together both the stakeholders of people who are interested in data and the people who produce data to answer the questions, what do we eat and where does it come from? What do we produce and where does it go? And what gets wasted along the way? I just chopped this out of my award letter to remind me to talk about it, but yeah, we the ink is still drying on a new project for us with the USDA to essentially redo the food composition database and ontologize it. Now, this is the food composition database that pretty much all food manufacturers in the United States and actually around the world use to talk about food components and reason over them. And we're also working with the cooperative extension to build ontologies around expertise of people who work in and around the food system. This was a poster that was at the recent International Conference for Biomedical Ontologies, and we'll be turning this into a full-blown paper very soon. We have another project, I think this is my last or second to last slide here, where we are looking at essentially engineering a social movement to capture the wisdom that our elders have about food. We're losing it. We're losing it faster, I would argue, than we're losing the rainforest. This wisdom is dying off with our elders, and it's quite a shame. So we'll be announcing this at the next IC Foods conference. Basically, 10 prizes for $10,000 each to make a video of an elder who's 2 generations older than you. I'll save the link for the tools there. You can go and explore it. This is our team and our partners, just some of them, and then a quick look at there. And I'll stop here, and if there's other questions after, or we can do that. Okay, thanks.
Yeah. Oh, thank you so much. Just in the interest of time, I want to open it up for maybe one quick question or comment while Gabe loads or takes over the screen control. And I've got a dentist appointment to move. I am very excited to be able to make the March IC Foods. And I'm not sad at all to move my teeth cleaning. So any quick questions?
I had a question, if that's okay. Ontologies are notoriously difficult to maintain and curate, and over time keep fresh. And the ontology that you described is scarier than any ontology I've ever seen.
So you're exactly right. So I'm gonna share my screen again really quick. All right. Gabe, did you already take the controls?
No, I didn't actually. I'm trying to find the controls on my screen. For some reason, they're gone.
Okay, great. So I'm gonna just take the controls really quick because I did skip one. So our answer to that is that we're building tools here. So I clicked on a link, but then share the right screen here. Okay, so can you see that little moving graph there?
Yeah.
Right. So I've got the kind of hacker mentality. Hackers tend to come into something and say, "This sucks," and everything sucks, right? And the goal is to make it suck less. And so I'm going to tell you that Protégé as an ontology editor sucks, and the current way that we track ontologies and update them is so complicated and heavy. And so we are working on, and actually we'll be putting in an NSF grant, and I think that this is actually going to align with what Gabe's going to tell you about too, because these ontologies can link to business use cases. But suffice it to say that you can drill through these concepts. This is the food on ontology that I'm a co-author on. And so I can, drill into various aspects of these things. What we don't have yet is a nice way to essentially, lasso these things and then edit that area. But what we've developed is a way for integrating ontologies. Like if I just say I want to link Kebi ontologies here, and I want to link this food antioxidant with this, some additive over here that might be an acidifier, and then I can say how they're related to each other. So this is easy. This is all browser based. It's super easy. The idea is that you'll be able to do this with other people in a browser. You don't need to be a PhD ontologist to do this stuff. That you could actually be a business person, and you could, so we don't know what exactly the hierarchy looks like for doing all of this, but we think that that there's the potential here to lower the barrier to entry and to divide and conquer. That's the strategy that we're going for.
Thanks. I'll avoid the 95 follow-on questions. This is really fascinating.
Yeah, I know. It's an ocean boiling exercise, and really, it's not gonna. We're not gonna do this ourselves, right? So that's what IC Foods, the consortium, is all about. Is about bringing people together and solving this problem. We're gonna boil the ocean with, 10 million candles, I guess, right? So I know there's, it's kind of crazy, but yeah, that's how we see it happening. I don't think it can happen any other way. I don't see how it can happen any other way. I could be wrong, but.
Well, and one of the reasons we invite people to present in this working group is, one, to connect people, and on top of just having UIs and functionality that makes my heart sing, and I don't use those words lightly or often. I just think this is such an interesting project, and I'm glad to hear there's lots of interest. I encourage you to, put IC Foods on your calendar and to follow up with Matthew in the interim. It's also so that we make sure we're building on and partnering with other groups and not duplicating or dreaming up solutions that have already been